This video was brought to you by the ILC. Hi there once again. Welcome to episode 24. In our last episode, we found the domain of a composite function. This time we're going to do another domain of a composite function. It's going to be a little bit more tricky than the last one, but it is doable. Let's get started now. Our functions this time are fx equals 2x divided by root x squared minus 4, and gx is equal to x plus 2. Once again, just like last time, we're going to have to first find the domain of f and the domain of g before we can go on and find the domain of f composite g. I'd actually like to start with g this time, because you can see g doesn't have any fractions in it, it doesn't have any roots in it, so g should give us no restrictions at all. That's the easy part. Now we'll look over here at f. Write it down over here. 2x divided by root of x squared minus 4. Let's look for roots, look for fractions. Well, the top here doesn't have any roots or fractions, so there's no restriction from the top either. But the bottom has a pretty nasty restriction. It is a root, and it's also a fraction. Now, from the root we know that we have to be greater than or equal to 0. But since it's also on the bottom of a fraction, it can't equal 0. So that's going to change the condition a little bit. If it says greater than or equal to, but then another restriction says not equal to, what does that leave? It's just got to be greater than 0. So this inequality will look a little bit different from the other roots that we've done. Let's try to set it up. We'll have x squared minus 4 greater than 0. Well, we can just move the 4 over to the other side. X squared is greater than 4. Then to find x, we'll have to take a root. But remember, when you take the root of an inequality, you'll end up with a positive version, but also a negative version. In the positive version, we just normally take the root. So we'll have x greater than, square root of 4 is, of course, 2. There's our first restriction. Now with the negative version, you change the sign of the inequality, and you change the sign of the number that you get. So we'll end up with x less than rather than greater than, and instead of saying 2, we'll say negative 2. So those are our two restrictions from this function. With those in mind, let's try to graph them. Well, as always, the left arrow is negative infinity, and the right arrow is positive infinity. Our 2 will be somewhere over here on the right side. Our negative 2 will be somewhere here on the left side. Now, according to what we've drawn, x has to be greater than 2. And notice it can't be equal to 2. So we'll put an open circle there, but we will say that greater than 2 is okay. I'll fill that in with green. From our second restriction, you see that it's got to be less than negative 2, so it can't be equal to negative 2. We'll put an open circle there as well. But everything that's less than negative 2 is okay, so I will fill that in green as well. Now anything that's between negative 2 and 2 cannot be in the domain either. So I'm going to put some x's there to show that anything in that middle region is excluded. With that in mind, we figured out where f and g are defined on the number line. So let's bring this over to the next page and try to figure out where the composite function is defined. I've gone ahead and cleaned up the line a little bit, so anything between negative 2 and 2 will be excluded. Let's figure out where the rest of our restrictions are when we write the composite function. Just like last time, we will begin by writing the first letter, that's f. 2x divided by root of x squared minus 4. We are going to replace the x's with g. So I have 2 times g divided by g squared minus 4. And then we'll replace the g with what the g is. So we'll have 2 times our g function is x plus 2 divided by x plus 2, the quantity squared, minus 4, square root. We can probably simplify this a little bit. On the top, we'll just FOIL this out. So we'll have 2 times x and 2 times 2, which becomes 2x plus 4. On the bottom, this could be a slight problem to FOIL out. Since we have a polynomial squared, we have to write it twice. We'll write our square root, x plus 2 times x plus 2, and then minus 4 on the outside. So if we FOIL this out, we'll have x times x is x squared, x times 2 is 2x, another 2 times x is another 2x, and 2 times 2 is 4, and then we have a minus 4, and all of it is still under the square root with our 2x plus 4 on top. We'll have to simplify this down a little bit before we can work with it, though. We have a 2x and a 2x becomes 4x. We have a plus 4 and a minus 4. They both cancel out. The x squared is unaffected, so we'll have x squared plus 4x underneath the square root, and then still 2x plus 4 on the top. Once again, we look at the roots, and we look at the fractions. On the top, we have no restrictions. And on the bottom, we have both a root and a fraction. And just like last time, when you have both on the bottom, the inequality must be greater than 0, because equal to is not allowed, just like last time. So we'll set up that inequality. X squared plus 4x is greater than 0. Now, since this is quadratic, we can't solve it the way we did last time. We're going to have to factor it. The only thing they have in common is x. Let's pull an x to the outside. You'll have x plus 4 left over if you pull out the x, greater than 0. So our points of interest are anywhere where this is 0. So if we solve the first piece, we'll have x equals 0 as our first point of interest, and then we'll have x plus 4 equals 0 as our second point of interest. We can just move the 4 over, and we'll have x equals negative 4. So here's our first point of interest. Here's our second point of interest. Let's mark them down. Here's 0. Now it's already in the restricted regions, so it won't do anything to our domain. But the negative 4 will, because it's not in the restricted regions. This is going to break our domain into 3 pieces. Between negative infinity and negative 4, we'll have piece A. Between negative 4 and negative 2, we'll have piece B. And between 2 and infinity, we'll have piece C. So if you'll recall what we did last time, we have to pick an x value from region A, B, and C, and see if it matches the condition that's listed in the inequality. Our condition is that it has to be positive, because it says greater than 0. So let's give it a try. First we go to region A, and we'll pick an x value. How about negative 5? It'll fall right there. So we'll have negative 5 times negative 5 plus 4. Well, if the first term's negative, the second term, negative 5 plus 4, will also be negative, and a negative times a negative gives you a positive. So everything in region A will be positive. That matches the condition we've listed. So region A will be part of the answer. Now go to region B. We'll have x equals something between negative 4 and negative 2. Let's try negative 3. So we'll have negative 3 times negative 3 plus 4. We have a negative here, and negative 3 plus 4 will be positive. So a negative times a positive gives us back a negative. However, that does not match the condition. So region B is not part of the answer. Next, go to region C. That's between 2 and infinity. We'll pick x equals 3. That'll fall right here in the region. We'll have 3 times 3 plus 4. Everything in this expression is positive, so this should return positive. So everything in region C will be positive, and note that also matches the condition. So your answer will be region A union region C. And the way we write it is like this. Go from region A, negative infinity, to negative 4, and then 2 to infinity. Since our condition did not contain an equal sign, it's just greater than, we just use all parentheses. That was a pretty nasty little problem there, but you're unlikely to see anything too much worse than this. Thanks for sticking with me through this whole thing. We'll see you again next episode.